So, radiation is produced when electrons make transitions from higher to lower energy levels. Which transition between these energy levels produces radiation of the shortest wavelength? Well, if it's got the shortest wavelength, then what that means is that your waves are as close together as they possibly can be. So if it's got the shortest wavelength here, lambda, then it must have the highest frequency. So you're looking for the energy that is associated with the highest frequency. And we know from E equals HF that frequency is directly proportional to energy, so we're looking for the biggest energy gap. So the biggest energy gap is going to occur with the biggest jump. So we're looking at E3 down to E0, because that's the biggest possible energy difference. And because we've got, if you think about how you're going to write out your explanation, E equals HF, H is a constant, Planck's constant is the same all the time. If that energy is the highest it possibly can be, then the frequency goes up. Then we're looking at the wave equation of V equals F lambda. V is the same for all electromagnetic radiation, so they all travel at 3 times 10 to the negative 8. Frequency is up. In order to keep this constant, then wavelength must go down. So you're really looking to say that the jump from E3 to E0, which is your answer, the jump from E3 to E0 is the highest energy difference, or has the highest energy difference, so therefore the photons required, or the photons emitted, will have the highest frequency. Highest frequency means that the wavelength is the shortest. Now B, you might have got a little bit confused with the different energy levels here and whether to use negative numbers or not. I tend not to use negative numbers, but it's not necessarily incorrect to use negative numbers. There are two ways that you can do this. I'll show you the way that I would do it. So frequency is basically equal to the change in energy divided by Planck's constant. So the change in energy here, as I've done it, is this level minus this level. I've done 9 times 10 to the negative 19 minus 5.2 times 10 to the negative 19, all over Planck's constant of 6.63 times 10 to the negative 34. Because remember, you don't necessarily need to use these negative values. They're just there to indicate that energy is being lost as you move down. The difference between these two negative numbers is going to be the same as between the two positive numbers, so that doesn't matter. What you also could have done here is done negative 5.2 times 10 to the negative 19 minus 9 times 10 to the negative 19, which would give you the same answer. It would give you 3.8 times 10 to the negative 19 divided by Planck's constant. And that will give you 5.7 times 10 to the 14 hertz. So you can figure out, just from knowing the energy levels from this energy level diagram, you can figure out what the difference is between these two levels. In this case it's these two. The difference there is delta E, and you can use that to figure out the frequency that's associated with it. It'll be delta E divided by H, which is just a rearrangement of E equals HF. You could also then go on and use that value of frequency along with velocity to figure out what the wavelength of the photon that is emitted, the wavelength of the radiation, and you could figure out what it is from a data sheet. You know, it could be ultraviolet, it could be green light, or anything like that.